it is pretty fitting that these are called cosmic flames. These packets are nothing but a bunch of different elements. So lithium makes red, barium makes green, and so on. And then they burn in these really pretty colors. Burning chemicals is a legitimate way to find out what something is. Chemists call it the burn test. All elements actually give off a signature when they are put into an excited state. Here, we are witnessing what happens in a fire. The James Webb Space Telescope will be able to read the same signatures from unknown stars and planets. I've been taking you through different elements that are built into the Webb telescope. Gold reflects infrared well and will not corrode. Beryllium is lightweight. Silicon is a tried and true semiconductor. Isn't it just poetic that Webb is designed to detect elements? Webb uses a device called a spectrograph. It works by splitting the light with a prism. We can tell what element we see based on the pattern from the light through the prism. Every element releases light at a different wavelength, and when that light is split by the prism, black bands appear due to the transition between the energy states. These are called absorption lines. The lines always appear in the same part of the rainbow, which is why we call them atomic fingerprints. I've made my own simple spectrograph to give you an idea about what Webb sees. And the object that makes this whole thing work is a relic of technology. It's a CD. CDs and DVDs use the same principle as another ancient device, the record. They use tiny tracks or bumps to convey the information. Records use a 3D representation of the sound, and a CD uses raised binary points. The point is that the discs have a very fine groove pattern that physically splits light. That's why they have a rainbow or iridescent color. Webb spectrograph also uses fine grooves to split light. The near-infrared spectrograph, called NIRSpec, is designed to take spectra from up to 100 objects at once. You don't need to go all the way to space to see the spectra from different objects. My little homemade spectrometer can tell me the primary element that different light sources use. Neon lights get their name because the lights use neon gases to get their color. Actually, the neon only refers to one color. These types of lights use other gases to make more colors. Let me show you the full spectrum of colors that we can see based on a combination of these different elements. Webb spectra really give more information than just the elemental makeup. They can also tell astronomers about the temperature, the mass, speed, and density of the objects as well. All elements have a cosmic start. Smaller elements are forged in the heat and pressure of a star. Anything larger than iron needs a powerful force of a supernova or colliding neutron stars. These elements may stay as dust clouds or eventually coalesce into asteroids or planets, characterized by their original elemental makeup. The spectra Webb will see not only tells us what elements we're looking at, but the warmth and the density of the bodies as well. So we might detect some distant biosignatures. Webb's build might use a scarce element like beryllium for its mirrors. But will this cosmically occasional element help us find something far rarer, like gaseous carbon, oxygen, or nitrogen? Can we determine where to find the building blocks of life in other worlds?